Alright, let's look at a couple examples where we have a variable on both sides of the equation. So in example 5, we have an a on both sides of that equal sign. And in example 6, we have multiple x's on both sides of that equal sign. So we're going to take into account what we just learned in the last lesson. And the first step is going to be to distribute. So I'm going to distribute this 1/2 times the a and 1/2 times the 6. And we know that 1/2 times a is 1/2 a. So it could be written as 0.5a, but that's writing it as a fraction. So 1/2 a plus 6 times 1/2. Well, what's half of 6? It's 3. So 6 times 1/2 is 3. And that equals 3/2 a minus 1. So we had to distribute. Take a look, do we need to combine like terms? Well, on both sides of the equal sign there's an a term and a non-variable term. So we don't need to combine any like terms. But now we do need to collect the variable on one side. And I always like to subtract the one that makes it so I don't end up with a negative number. If I subtracted 3/2, don't do this, from each side. You could do this. I would recommend not doing it. If you subtracted 3/2 from both sides, then we would end up with a negative on the other side. We'd have a negative a. So we don't want to do that. Let's instead subtract 1/2 a from both sides and see where that gets us. So we have 1/2 a minus 1/2 a is just 0. So on the left side, the only thing that survives is that plus 3. Let's actually switch back to blue. So we just have that plus 3. And then equals, well, what's 3/2 minus 1/2? 3 minus 1 is 2 over 2. So 2 over 2 is also equal to 1. So that's what we have left over there. We have 3/2 a minus 1/2 a is just 1a. And then we have the minus 1 left over right there. And then, really simple at this point, you just have to continue to get a by itself. We have to add 1 to both sides, and we get that a equals 4. And so that's our answer for that one. So we had to distribute. We didn't have to combine like terms, but then we collected all of our a terms to one side, and then we added and subtracted. Didn't have to multiply or divide. Okay. So example 6. Well, we don't need to distribute. Looks like we do need to combine like terms though. So we have a 10 that we can combine with a plus 1. So 10 plus 1 is 11 minus 5x. And that equals, well, what can we combine with this 7x? We can combine this negative 12x. So if we have 7 minus 12, that gives us a negative 5x plus 11. Alright, so now we're going to collect the variables onto one side. We combine like terms. We need to get all of the x's to one side. Well, if we look on the left, we have 11 minus 5x. So let's go ahead and add 5x to that one. And we're going to add 5x to both sides. And on the left side, we get 11 and then negative 5x plus 5x. That's going to zero out. So 11 equals, and on the right side we have negative 5x plus 5x. And hopefully you're starting to see that this is a little bit strange of a problem. Negative 5x plus 5x is 0. So we just have an 11 on that side. So instead of getting a letter equal to a number like we did in the last problem, we're getting a number equals a number. And so there's two different things that can happen in this situation where we get all of our variables to cancel out as they did in this one. So this happens when the variables cancel itself out, but the equation is still equal. So the equation is still equal. So this is going to be called, you're going to want to write this definition down. This is an identity. Think about someone's identity. It's who they are. And mathematically, 11, what 11 is 11, which may or may not be a good example, but that's kind of to explain what an identity is. So an identity happens when the variables cancel out. All of those x's went away. So it's an identity if it has infinitely many solutions. So once you get to 11 equals 11, you're not done. You're going to want to say identity. You've got to write that. And then it has infinitely many solutions. And we've seen this symbol before. The solutions would be all real numbers. So you could say x equals all real numbers, because we could put any number in for x and we would still get 11 equals 11. Or we would still get a number equals and then that same number. So no matter what you put in for x, that's going to be true. The other example would be, and your other vocab word, which will come up half of the time, is a contradiction. And that would be, say, instead of an 11 on the left side, we had a 12. And it was 12 equals 11. Well, that 12 does not equal 11, so that would be a contradiction. So it would be as simple as that. So if the variables go away like that, if it's equal to each other, then it's an identity. And if they're not equal, if it's 12 equals 11, well, that's not true. So that would be a contradiction. So is an equation that is not true for any value of the variable. It has no solutions. So if you got 12 equals 11, you would put that mark through it. You would write contradiction. And you would say no solutions. And you would be done. And so those are special cases. You'll see both of those in different places throughout the homework. So make sure that you're watching out for those, and that a bell should be going off if you see something where the variables are canceling out. So at this point, you're ready to try the homework.